Okay, Kamari, I'm going to catch you up on what we're doing in math. I saw that you tried that assignment today in math. You got some mistakes on it, so I sent it back to you and give you a chance to fix it up after you looked at this lesson with me, okay? So let's go ahead and look at what we are talking about here. We're talking about equivalent fractions. Remember, an equivalent fraction means that they show the same amount. For example, if you have 1/2 like this, that's 1/2. Well, if I make the same 1/2, like do the exact same thing, so here's 1/2 again, and say I double the parts, all right? I change it from 2 parts to 4 parts. Well, you'll notice the same amount is colored, right? The amount that was colored in did not change, but now look, the number of parts changed though. We've got 1, 2, 3, 4 parts, and 2 of them are colored. But we can see that the same amount of the rectangle is colored, so we can say that 1/2 and 2/4 are the same. 1/2 is equivalent to 2/4. 1/2 is equivalent to 2/4. Okay. And we could change it up other ways too. Like I could go back to this and change it. So now I've got, instead of 2 parts, I got 1, 2, 3, 4, 5, 6 parts. And 3 of them colored in, that's 3/6. Well, then we could say that 3/6 is also equivalent to 1/2. All right. So what we're going to do today is show how we can create equivalent fractions by using pictures. Okay. And also how we can identify equivalent fractions using pictures. So let's take a look here at, let's say, let's look at the fraction 2/3. So 2/3 looks like this. Got 3 parts, and then we color in 2 of them. So there we've got 2/3, right? Let's think. How could we change 2/3 to create an equivalent fraction? Let's make another rectangle. Same thing. Put it in the thirds, just like the other one. Color in 2 of them. And now what if we, after we've done this, what if we do this right here? Well, we multiplied the number of parts by 2, didn't we? We've gone from 3 parts to 6 parts, and the green parts, there's 2 of them, now there's 4 of them. But you can see the same amount is colored green. The amount that was colored green did not change. What did change is the number of parts. We now have 6 total parts, and 4 of them are colored in. But you can see that this amount here is the same as this amount here. The amount that's colored in did not change. So we can see that 2/3 is equivalent to 4/6. 2/3 is equivalent to 4/6. And we could create more equivalent fractions to 2/3. We can make an endless number of equivalent fractions to 2/3. What if we've got 2/3 again, and what if we split it up this way? Now we've multiplied the total number of parts by 3, right? So now we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 parts. And 6 of them are colored in. So we could say that 2/3 is equivalent to 6/9. And we could do this forever, right? We could make one after the other. We could split it like this again, but then split it like this. Now we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 parts. And 1, 2, 3, 4, 5, 6, 7, 8 of them colored in. 8/12. 8/12 also equivalent to 2/3. All these fractions, 4/6, 6/9, 8/12, they're all equivalent to 2/3. So you notice in all of these, the amount that's colored in never changes. Even though the number of parts changes, the amount that's colored in never changes. So what if I wanted to prove, let somebody said, what's an equivalent fraction to 3/4? And I told them that 9/12 is equivalent to 3/4. And they say, well, prove it. Okay. So first thing I'm going to do is create 3/4. So there's 4 parts. Color in 3 of them. So 1, 2, 3, 4 parts, and 1, 2, 3 of them colored in. That's 3/4. We agree that's 3/4. Well, let's think. We want to change this now so that there's 12 parts and 9 of them colored in. Well, to get from 4 to 12, I'm going to need to multiply these by 3, right? So if I just make these 2 lines, now I can see that I've got 12 parts and 9 of them colored in. The amount of green never changed, did it? It stayed the same. But now we've gone from 4 parts to 12 parts, and we've gone from 3 parts colored in to 9 parts colored in. So that proves it with your picture. Let's do another one of those. I'll show you what you'll need to do. You only need to do one like this on the assignment today in Seesaw. Okay. And I want you to pay attention on Seesaw, Kamari. There's lines like this, on the page, making this kind of grid pattern, right? I want you to use those lines to create your fraction, to create your pictures, right? Use the lines. I saw the way you did it so far is you're just kind of making, big lines like this, and then just, coloring them in, without paying any attention to not paying attention to any lines that are on the paper, right? You just did it like that. Well, what you really need to do, Kamari, is on that page, use the lines on the paper. All right. Okay, so let's say you're trying to make a picture of a fraction. Well, then make your lines go right along the checkered lines like this. All right. And create your fraction pictures that way. Like here we're showing, if you're showing 1/3, it look like that, right? But make sure you make your fraction pictures right along the lines. Use the lines on the paper, on the page. All right. So anyway, let's do one more of the list where you prove that 2 fractions are equivalent using a picture. All right. So let's say you tell somebody, I know that, I don't know, let's do 1/2. 1/2 is equivalent to 4/8. I'm like, well, prove it. All right, fine, I will. So I'd make 1/2. Do it like that. So that's 1/2. All right. Well, now you want to show that 4/8 is the same as 1/2. We'll make the exact same rectangle as best you can, and split it into 1/2 again, in halves. Show that 1/2 again. But now you need to make lines to show that you've got 8 parts. Well, I need to go from 2 parts to 8 parts. And I know how I can do that. I can just multiply the parts by 4. So I'm going to multiply by 4 by putting in lines like this. So now I've got 1, 2, 3, 4, 5, 6, 7, 8 parts, and 4 of them are colored in. And you notice that the amount colored in is the same in both, right? So that shows you that 1/2 and 4/8 are equivalent. All right. So that's just a way that you can use pictures to prove that fractions are equivalent. You can also use pictures to create equivalent fractions. So let's say you have 3/10 or 3/5. All right, so 3/5. And I want you to create for me an equivalent fraction. Well, let's first make fifths, and let's color in three of them. So there's 3/5. Well, you could create an equivalent fraction just by simply doing this. Just take the same picture and multiply the parts by 2. Now you've got 10 parts and 6 of them colored in. And there you go. So the amount that's colored green never changed, did it? Never changes, but the number of parts did. And you can make even more. What if we did this? Make lines like this. Split them all even more. Now we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts and 20. All right. So now we could say, and then there's 1, 2, 3, 4, 5, 6, 7, 8, 9. We could say that there's 12 colored in. So now we got 12 20ths colored in. And you could do that forever. I mean, it'd make your picture a sloppy mess, but I think you get the idea now how you can use pictures to show that fractions are equivalent, and you can use pictures to create more equivalent fractions. All right. So go ahead and give that assignment another try. Hopefully you understand it a little bit better. I'm very much looking forward to you being back in school on April 5th, so that'll make the teaching a lot easier too. So, all right, talk to you later.